Before we begin, a quick note. This video is for educational and entertainment purposes only. The mental exercises and tricks we'll discuss are designed to sharpen your cognitive skills, but they are not a substitute for professional medical advice regarding brain health or any cognitive conditions. The check arrives. Your heart does that tiny little dip. It's not the price. It's the math. You're with friends, you're on a date, you're at a business lunch, and the waiter places that little black folder on the table. The conversation pauses. All eyes are on the bill. And your mind, which was just brilliantly debating the finer points of last night's game or a new streaming series, suddenly feels like an old dial-up modem trying to connect to the internet. You see the total. $132.54. And now the tip. Is it 15%? 18? 20? You start to do the calculation in your head. 132, 10% is 13.20, so 20% is 26.40. And then you have to add the 54 cents, and your brain just freezes. You feel a flush of pressure. So what do? You do what we all do. You pull out your phone, slide your thumb over to the calculator app, and tap in the numbers like you're defusing a bomb. It's a moment of quiet defeat, a tiny surrender to the little computer in your pocket. You know that feeling, right? That feeling that your brain has become a little soft, that the mental muscle you used to remember phone numbers, navigate without GPS, or do simple math has been outsourced. Your phone has become a crutch, and your brain is starting to forget how to walk on its own. It's not your fault. We live in an age of digital convenience. But what if I told you that you could reclaim that power? What if I told you that you have a supercomputer sitting right between your ears, and all you need is the right software to unlock it? What if you could calculate that 20% tip faster than your friend can even find their calculator app? Not just to save a few seconds of embarrassment, but to feel sharper, quicker, and more in control. To feel smarter. Because mental math isn't a gift you're born with. It is not some secret genius gene. It's a skill. It's a set of tricks. It's a system. And today I'm going to give you the first key to that system. By the end of this video, you will not only be able to solve specific types of math problems in your head instantly, you will start to see numbers in a whole new way, not as scary, rigid things, but as playful, flexible concepts you can bend to your will. We're going to turn that feeling of mental fog into a feeling of mental firepower. Let's start with something that seems deceptively simple, but its application is mind-blowing. We're going to learn how to multiply any two-digit number by 11, instantly. You're thinking, okay, why 11? Stick with me. This is the warm-up. This is the first push-up in our brain-building workout, and it's going to show you just how easy this can be. Here's the secret. It's a simple three-step process. Take any two-digit number. Let's say 34. To multiply 34 by 11, you don't need a calculator. You just need to look at the number 34. First, you take the two digits, the 3 and the 4, and you split them apart, leaving a space in the middle. So you have a 3, a space, and a 4. Now for the second step, you add those same two digits together. 3 plus 4 equals 7. The final step, you take that sum, the 7, and you place it right in that middle space. So you have 374. 374. 34 times 11 is 374. Go ahead, check it on your calculator. Oh wait. See? It's not magic, it's a method. Your brain just did that. No pen, no paper, no phone. Let's try another one just to prove it wasn't a fluke. How about 52 times 11? Okay, step 1, split the 5 and the 2. You have 5 space 2. Step 2, add them together. 5 plus 2 is 7. Step 3, put the 7 in the middle. 572. That's it. You just did it again. You're literally doing math at the speed of thought. Right now, you're probably feeling a little jolt of excitement. This is your brain waking up. But you might also be thinking, okay, what happens if the two numbers add up to more than 9? Great question. This is where the trick goes from a cool party gag to a genuinely powerful tool. This is where we learn to carry the 1, and it's just as easy. Let's take the number 78. We want to multiply 78 by 11. We follow the same rules. Step 1, split the 7 and the 8. We have 7 space 8. Step 2, add them together. 7 plus 8 is 15. Now we can't just shove 15 into that middle space. That would give us 7,158, which is obviously wrong. So here's the rule. When your sum is a two-digit number, you leave the second digit in the middle space, and you carry the first digit over to the front. So for 78, the sum was 15. We put the 5 in the middle, And we take the 1 from 15 and we carry it over, adding it to the first digit, the 7. So 7 plus that carried 1 becomes 8. Our new first digit is 8. The middle digit is 5. The last digit is 8. 858. 78 times 11 is 858. Let's do one more together, a tough one. How about 95 times 11? Take a second. Try it in your head right now. Don't just watch, participate. This is your brain workout. Okay, you got it? Let's break it down. Split the 9 and the 5. 9 space 5. Add them together. 9 plus 5 is 14. It's a 2-digit sum, so we know what to do. We put the 4 in the middle space. We carry the 1 from the 14 over to the very first digit, the 9. 9 plus that carried 1 is 10. So our new first number is 10. The middle number is 4. The last number is 5. The answer is 1045. Think about what just happened. A few minutes ago, you probably would have reached for a calculator to solve 95 times 11. Now you just did it in your head. You visualized it, you manipulated the numbers, and you got the right answer. This isn't just about the number 11. This is a fundamental principle. We're breaking a complex problem, multiplication, into a simple one, addition. We're taking something that looks intimidating and revealing the simple, elegant pattern hiding just beneath the surface. This is what mental athletes do. They don't have different brains. They just have a different set of rules for the game. And you've just learned one of the most important rules. You've taken your first real step to reclaiming your brain's natural mathematical ability. You've proven to yourself that you can do this. And the trick for multiplying by 11 is just the first key. It's the tool that opens the door. But now that the door is open, what are we going to do with it? After all, you don't multiply by 11 every single day. But you do deal with something else constantly. At the store, at a restaurant, when you're looking at your finances, percentages. Calculating a 15, 18, or 20% tip is a daily American ritual. And the same principle we just used, breaking a big problem down into tiny, easy pieces, is the exact same secret we're going to use to make you a master of percentages. We're going to build on this foundation, and I'm going to show you how to calculate any tip on any bill in less than 3 seconds. Let's start with the scene I guarantee you know all too well. You're at a restaurant. The food was great, the conversation was even better. And then it arrives. The bill. It's placed on the table and suddenly, a tiny cloud of social anxiety descends. Your friends are all looking at you. You're looking at them. And everyone is secretly thinking the same thing. What's the tip? Someone pulls out their phone. They unlock it, swipe a few times, and open the calculator app. They start punching in the numbers, maybe they mess it up once and the whole table just waits. It's a moment of collective brain freeze. A tiny awkward pause in an otherwise perfect evening. That little calculator app is a crutch. And today we are going to break that crutch forever. You will be the person who glances at the bill for a single second, says the exact tip amount, and moves on with your life while everyone else is still searching for their phone. How? By mastering the single most powerful tool in the world of percentages. The 10% trick. So simple it feels like cheating. To find 10% of any number, you just move the decimal point one place to the left. That's it. That's the entire trick. If the bill is $80, 10% is $8. If it's $120, 10% is $12. If it's $67, 10% is $6.70. The decimal point is like a shy friend at a party. It's always there at the end of a number, even if you don't see it. $80 is just 80.00. Move that point one spot to the left and you get 8.00. $8. You can do this with any number, and you can do it instantly. Now you might be thinking, okay, great, but I don't tip 10%. I usually tip 20%. Perfect. If you can find 10%, you can find 20%. How? You just double it. It's that simple. Let's go back to that $80 bill. You glance at it. Your brain doesn't see 80. Sees 8. That's your 10%. What's 8 plus 8? 16. The tip is $16. The total is 96. You did that in the time it took me to say it. While your friend is still typing 8 to 0 into their calculator, you already know the answer. Let's try another one. The bill is $130. What's the first thing you see? Not 130. You see 13. That's 10%. What's 13 doubled? 26. The tip is $26. Done. You've just calculated a 20% tip in your head with zero stress. But this is where it gets really beautiful. This is where we start combining our building blocks. What if you want to leave a 15% tip? This is the one that trips most people up. But for you it's going to be effortless. Because what is 15%? It's just 10% plus 5%. And what is 5%? It's just half of 10%. You see where this is going? You're not calculating 15%. You're just doing two incredibly simple things, finding 10% and then cutting it in half. Let's take a tricky one. The bill is $74. The calculator is already starting to sweat. But not you. You glance at 74. The first thing your brain does is move the decimal. 10% is $7.40. Now what's half of that? Don't panic at the weird number. Break it down. What's half of $7? $3.50. What's half of 40 cents? 20 cents. Add them together. $3.50 plus 20 cents is $3.70. So 5% is $3.70. Now you just add your two pieces together. Your 10% piece $7.40 and your 5% piece $3.70. Let's do it. $7 plus $3 is $10. 40 cents plus 70 cents is $1.10. So the total tip is $11.10. It might seem like a lot of steps when I say it slowly, but in your head it happens in a flash. You see 74. Your brain goes, 10% is $7.40. Half of that is $3.70. Add them up. $11.10. Done. You are a human calculator. This isn't just a party trick. This is a fundamental shift in how you see numbers. You're no longer intimidated by them. You see them as simple, modular pieces you can take apart and put back together however you want. Let's leave the restaurant and walk into a store. There's a jacket you like. It costs $160. But today there's a 30% off sale. The old you would pull out your phone. The new you see is $160. Your brain immediately fires. 10% is 16. The sale is 30%, so that's 3 of those 10% blocks. What's 3 times 16? Well, we learned how to do that in the last part. 3 times 10 is 30. 3 times 6 is 18. 30 plus 18 is 48. The discount is $48. You instantly know the store is going to take $48 off the price. You didn't calculate 160 times 0.30. You just saw 16 and multiplied it by 3. You're thinking in a completely different language. And we can go deeper. This building block approach lets you calculate any percentage with pinpoint accuracy. Let's say you want to leave an 18% tip because the service was good but not quite 20% amazing. How do you do that? Most people would just give up and round to 20. Not you. You have options. You could take your 20% amount and subtract 2%. Or you could take your 15% amount and add 3%. The point is, you have the tools. You just need one more tiny building block, the 1% trick. And it's exactly what you think it is. To find 1% of any number, you just move the decimal point 2 places to the left. So on that $80 bill, 1% is 80 cents. 10% is $8. 1% is 80 cents. See the pattern? It's always just a matter of moving that decimal. So, if you want to calculate a precise 18% tip on that $80 bill, you can start with 20%, which we know is $16. Now you just need to subtract 2%. If 1% is 80 cents, then 2% is $1.60. So you take your $16, subtract $1.60, and you get $14.40. That is the exact 18% tip, and you just figured it out in your head. Is this practical for every single situation? Maybe not. Maybe you're happy just rounding to 15 or 20%. But that's not the point. The point is that you can. You have the power and the confidence to manipulate these numbers at will. You are no longer at the mercy of a calculator. You have unlocked a new level of numerical fluency. You're not just memorizing tricks. You're understanding the fundamental structure of numbers. The 10% block and the 1% block are like the Lego bricks of the percentage world. Once you have them, you can build anything. A 17% tip? That's 10% plus 5% plus 2 1%. A 35% discount? That's 3 10% plus a 5%. You see the grid, the matrix behind the numbers. This is a true mental superpower. It saves you time, it saves you from that awkward fumbling for your phone, and it builds a deep, unshakable confidence in your own mind. You start to trust your own intuition because you've given it the tools to be right. You'll find yourself doing it automatically. Walking past a real estate sign, you'll see the price of a house and instantly know what a 3% commission would be. You'll hear a statistic in the news, and you'll be able to quickly calculate the real-world impact. You're not just learning mental math, you're learning to see the world more clearly. We've just turned percentages, one of the most feared concepts in math, into a simple game of moving a decimal point and adding or subtracting small, easy numbers. We took a big scary problem and broke it down into bite-sized pieces. And this is just the beginning. This idea of breaking things down, of finding the 10% and 1% building blocks applies everywhere. But what about when we have to go the other way? What about when you're given the final price with tax included, and you need to figure out what the original price was? It seems impossible, like trying to unbake a cake. But there's a beautifully simple way to do it, and it involves a little bit of what I call reverse engineering the math. It's the next tool for your mental toolkit, and it's going to make you feel like a financial detective. Let's start with a classic scenario. You're at the mall, and you see a sign that screams, 40% OFF everything. You find a jacket you love, and the price on the tag is $120. You take it to the register, happy with your find. The cashier scans it and says, "That'll be $72. You pay, you leave, and you're feeling great. But later that night, a friend asks you, "Wow, great jacket. How much was it originally?" And you freeze. You know you paid $72 and you know it was 40% off, but what was that original number on the tag? Now, here's what 99% of people do. They take the price they paid, $72, and they try to add 40% back on. So they think, okay, what's 40% of 72? Well, 10% is 7.2, so 40% is 4 times that, which is 28.8. So they add it back on. 72 plus 28.8 is $100.80. And they tell their friend, it was about $100. But we know that's not right. The tag said $120. So what just happened? Why did the math lie to us? It's because you took 40% of the wrong number. You took 40% of the sale price, but the store took 40% off the original price. Those are two completely different calculations. This is that unbaking the cake problem I mentioned. Trying to add the percentage back on is like trying to put the eggs and flour back into the box after the cake is already on the cooling rack. It just doesn't work. So, how does the financial detective solve this? They don't try to go forward. They reverse engineer the crime scene. They ask a different question. Instead of focusing on the 40% that was taken away, they focus on the percentage that was left. If an item is 40% off, what percentage of the price did you actually pay? You paid 100% minus 40%, which is 60%. So that $72 you paid for the jacket, that is 60% of the original price. Now we have a clue we can actually work with. The statement isn't, I need to add 40% to 72. The statement is, $72 is 60% of what number? And whenever you want to find that what number, you just divide. You take the part you have, $72, and divide it by the percentage it represents, 60% or 0.6. Now I know what you're thinking. Great. Now I have to do 72 divided by 0.6 in my head? That's not mental math, that's a mental meltdown. But stick with me because this is where the real magic happens. We're going to turn that ugly division into a beautiful, simple multiplication. The key is to think of percentages as fractions. What is 60% as a simple fraction? It's 6 out of 10 or 6 out of 10, which simplifies down to 3 out of 5. 3/5. So the problem is now 72 divided by March 5th. And do you remember that one rule from grade school math that you thought you'd never use? To divide by a fraction, you flip it over and multiply. So instead of dividing by 3/5, we are going to multiply by May 3rd. Now look at what we have, 72 times 5/3. This is so much easier. Let's do the division part first. What's 72 divided by 3? If you don't know offhand, break it down. 60 divided by 3 is 20. 12 divided by 3 is 4. So 72 divided by 3 is 24. Now we just have one step left. Multiply that 24 by the 5 on top. 24 times 5. Well, 20 times 5 is 100. 4 times 5 is 20. Add them together and you get 120. There it is. The original price. $120. No weird decimals, no calculators, no guessing. You just flipped the problem on its head, turned a percentage into a fraction, and solved it in 2 simple steps. This is the detective's secret weapon. Let's try another one, faster this time. You're at a bookstore with a 25% off store-wide sale. You buy a stack of books and your total comes to $90. What was the original price? Okay, detective. First question. If it's 25% off, what percentage did you pay? You paid 75%. So, $90 is 75% of the original price. Second step, turn that percentage into a fraction. 75% is one of the easiest ones. It's 3/4. Third step, instead of dividing $90 by 3/4, we're going to multiply $90 by April 3rd. Let's do the math. What's 90 divided by 3? That's 30. What's 30 multiplied by 4? 120. The original price of your books was $120. You can do this in about 5 seconds in your head while the cashier is bagging your books. This trick works for any discount. 20% off? That means you paid 80%, which is the fraction 4/5. To find the original price, you multiply the sale price by May 4th. 30% off? You paid 70% or 7/10. So you multiply by October 7th. But this reverse engineering goes even deeper. It's not just for discounts. What about the opposite? What about when money is added on? I'm talking about the most common addition of all, sales tax. You're out to dinner with the client. The final bill, with tax included, comes to $108. The sales tax in your city is 8%. Your company's expense policy says you can expense the food, but not the tax. So you need to know the pre-tax amount. How do you find it? Once again, most people will make the same mistake. They'll try to calculate 8% of the total bill and subtract it. But that's unbaking the cake again. The 8% tax was calculated on the original smaller food bill, not the final larger total. So let's be detectives. The original food bill is our starting point. We can call that 100%. The government then added 8% tax on top of that. So, what percentage does that final $108 bill represent? It represents 100% of the food plus 8% of the tax, for a grand total of 108% of the original amount. So the clue is this: $108 is 108% of the pre-tax bill. To find the original, we need to do what we did before, divide. We need to calculate 108 divided by 108%, or 1.08. And this is where most people's brains just turn off. 108 divided by 1.08? No thank you. But financial detectives know there's a much simpler way. Instead of working backward with that horrible division, we can just work forward with a smart guess. Look at the numbers. We're dividing 108 by a number that's a little bit more than 1. So we know the answer is going to be a little bit less than 108. And what's the cleanest, roundest, most beautiful number in that neighborhood? It's 100. So let's just pretend for a second that the pre-tax bill was exactly $100. What would the final bill be? Well, we'd start with $100 and we'd add 8% tax. What's 8% of $100? It's just $8. So the total would be $100 plus $8, which is $108. And just like that, you've solved it. The pre-tax bill was $100. You didn't have to do any complex division. You just made an educated guess and proved it with a simple addition. This work-forward method is incredibly powerful because restaurant and retail prices are almost always set at clean, round numbers. The messy numbers only show up after the tax is added. Let's try one more, a slightly harder one. You just bought a new TV. The final price on your credit card statement, including a 7% sales tax, is $802.50. You want to know the shelf price of the TV. Okay, let's reverse engineer it. The shelf price is 100%. The tax is 7%. So that $802.50 represents 107% of the shelf price. That means we need to calculate 802.50 divided by 1.07. Again, that sounds like a nightmare. So let's work forward instead. Let's make a guess for the shelf price. It's probably a nice round number. What's a likely price for a TV in that range? Maybe $700? Let's test it. What's 7% of $700? Well, 1% of 700 is 7. So 7% is 7 times 7, which is $49. So the total price would be $700 plus $49 equals $749. That's a bit low. We're looking for $802.50. So let's guess higher. What about $750? This is a bit trickier, but we can do it. What is 7% of $750? Let's break it down. 7% of $700 we already know is $49. Now we just need 7% of the remaining $50. Well, 10% of 50 is 5. 1% is 0.5. So 7% would be 7 times 0.5, which is $3.50. Now we add our two parts together. $49 from the $700 plus $3.50 from the $50. That gives us a total tax of $52.50. Now for the final step. Add the tax to our guess. $750 plus $52.50 is $802.50. Bang! We hit it exactly. The shelf price of the TV was $750. You just solved a problem that would make most people reach for a calculator, and you did it by combining a smart guess with the percentage tricks we learned earlier. This mindset shift, from trying to subtract a percentage to understanding what percentage you're truly working with, is the key. It lets you reframe the problem into something your brain can handle easily. It works for discounts, it works for taxes, it works for investment returns. It's a universal tool for seeing the hidden numbers that control our financial lives. We've learned how to work backward and how to deconstruct ugly problems. But what about when the problem itself just starts out ugly? I'm talking about multiplying two awkward numbers like 64 times 75. It seems clunky and slow, destined for a calculator. But there's a way to transform these ugly numbers into friendly ones, making the calculation almost instant. It's like having a mathematical magic wand, and it's the next tool we're going to add to your kit. This magic wand is a principle, an idea so simple yet so powerful it will change the way you look at numbers forever. It's called the compensation method. It sounds a bit formal, like something you file with an insurance company, but in practice it's the most natural, intuitive way to do math. The core idea is this. If a number is ugly and difficult, change it into a pretty, friendly number. Do your calculation with a friendly number, and then, and this is the crucial part, compensate for the change you made. You just fix it at the end. Let's see it in action. Imagine you're at a coffee shop. Your order comes to $4.97. The barista, looking a little stressed, asks if you have exact change. You don't. But then you buy a pack of gum for $2.55. What's the new total? 497 plus 255. Your brain might start to groan. You picture the numbers stacked on top of each other. 7 plus 5 is 12, carry the 1. 9 plus 5 is 14, plus the 1 is 15, carry the 1. It's slow, it's clunky, and you're holding up the line. Now let's wave the magic wand. The ugly number here is 497. It's so painfully close to a beautiful, round, friendly number. 500. So let's just pretend it is 500. Just borrow 3 cents from the universe for a second. Now the problem is 500 plus 255. Can you do that? Of course you can. It's 755. It's instant. But wait, we have to pay the universe back. We pretended 497 was 500, which means we added 3 to it. To make things right, to compensate, we just have to take that 3 away from our answer. So 755 minus 3. The answer is 752. Or, in this case, $7.52. No caring, no struggle. You just nudged a number to make it easy, did the simple math, and then nudged the answer back. This works everywhere. What about 898 plus 340? Don't you dare start carrying the 1. 898 is ugly. Its friendly neighbor 900 is beautiful. Let's make the switch. We'll add 2 to 898 to get 900. Now the problem is 900 plus 340. That's 1,240. Easy. Now we just compensate. We added 2 at the start, so we subtract 2 at the end. 1240 minus 2 is 1,238. You can do this in the time it takes someone else to even start writing the problem down. And what if both numbers are ugly? What about 697 plus 195? This looks like a monster. But with our wand, it's a kitten. Let's make them both friendly. 697 is just 3 away from 700. And 195 is just 5 away from 200. Let's do it. The problem becomes 700 plus 200. The answer is 900. Now we just have to settle our debts. We added 3 to the first number and 5 to the second number. In total we added 8. So, to compensate, we subtract 8 from our easy answer. 900 minus 8 is 892. Think about how you would have done that otherwise. All that carrying and mental clutter gone, replaced by a single, simple subtraction at the end. This principle is even more of a lifesaver in subtraction, especially with problems that are designed to make you miserable. You know the ones I'm talking about. Problems like 1,000 minus 473. Or even worse, 602 minus 399. That second one is a nightmare on paper. You have to borrow from the 0, which means you have to borrow from the 6. It's a chain reaction of borrowing that trips up even smart people. But we're not going to do that. We're going to use compensation. The problem is 602 minus 399. The ugly number is 399. So close to 400. Let's just subtract 400 instead. It's much easier. 602 minus 400 is 202. We can all do that in a split second. But did we subtract the right amount? No. We were supposed to subtract 399, but we got overeager and subtracted 400. We subtracted one too many. To fix this, to compensate, we just have to give that one back. So we add 1 to our answer. 202 plus 1 is 203. And that's our answer. 602 minus 399 is 203. We turned a borrowing nightmare into a simple subtraction, and an even simpler addition. Let's try another one. 805 minus 49. Don't start borrowing. 49 is almost 50. Let's just do 805 minus 50. That's 755. But again, we subtracted one too many. So we add that one back. 755 plus 1 is 756. It's a pattern. When you round the number you're subtracting up, you always add the difference back to your final answer. It's like paying for a $49 item with a $50 bill. You overpaid by $1, so you get $1 back in change. Same exact logic. Now this is where the magic really starts to sparkle. We've used this for addition and subtraction. But what happens when we apply the same logic, the logic of friendly numbers and compensation, to multiplication? This is where you go from being quick with numbers to looking like a real-life wizard. Let's take a problem like 38 times 5. Okay, you could do it the long way. 8 times 5 is 40, write the 0, carry the 4. 3 times 5 is 15, plus the 4 is 19. The answer is 190. It works. But it's a process. Takes a few mental steps. Let's try it with compensation. 38 is the ugly number. Its friendly neighbor is 40. So let's calculate 40 times 5 instead. That's incredibly easy. 4 times 5 is 20, add the 0, you get 200. Now we have to compensate. We were supposed to calculate 38 groups of 5. Instead, we calculated 40 groups of 5. That means we calculated 2 extra groups of 5. What are 2 groups of 5? Well, 2 times 5 is 10. So our answer of 200 is too high by 10. To fix it, we just subtract that 10. 200 minus 10 is 190. Same answer, but the mental pathway is so much smoother. This technique, which is really just the distributive property in disguise, is a powerhouse. Let's try a bigger one. 79 times 8. The ugly number is 79. Let's round it up to 80. The easy problem is 80 times 8. 8 times 8 is 64, add the 0, you get 640. We wanted 79 eighths, but we calculated 80 eighths. We're over by one group of 8. So we just subtract 8 from our answer. 640 minus 8 is 632. Instantly. This next one is a party trick. It's a specific application of this rule that is so clean and so fast, people will think you've memorized the multiplication tables up to 100. It works for multiplying two numbers that are equally distant from a nice, round, friendly number. For example, 29 times 31. Notice that 29 is 1 less than 30, and 31 is 1 more than 30. They're neighbors of 30. When you see a problem like this, here's what you do. First, take that middle number 30 and multiply it by itself. 30 times 30. That's 900. Now, look at the distance from the middle number to your original numbers. The distance was 1, right? 29 is 30 minus 1, and 31 is 30 plus 1. So, take that distance 1 and multiply it by itself. 1 times 1 is 1. Now for the final step. Take your first result and subtract your second result. 900 minus 1 is 899. That's your answer. 29 times 31 is 899. Let's do it again. 48 times 52. What's the friendly number right in the middle? 50. What's 50 times 50? 5 times 5 is 25, add 2 zeros. 2500. Now what's the distance from 50 to 48 and 52? The distance is 2. What's 2 times 2? It's 4. Now subtract. 2500 minus 4 is 2496. And you have your answer while someone else is still reaching for their phone. This is a beautiful piece of mathematical symmetry. What you're really doing is calculating 50 minus 2 times 50 plus 2, which is the same as 50 squared minus 2 squared. But you don't need to know the algebra. You just need to see the pattern. This one concept of making numbers friendly and then paying back your debt is a universal key. It unlocks faster, more intuitive calculations across the board. It's not about memorizing 100 different tricks. It's about understanding one powerful idea, the idea that you are in control. You can change the numbers to suit you, as long as you remember to balance the books at the end. This is more than a trick. It's a shift in mindset. You stop seeing problems as rigid and fixed, and start seeing them as flexible and solvable. But what happens when the numbers aren't so close to a round number? What about a problem like 35 times 12? Rounding and compensating isn't as clean here. For that, we need a different kind of tool. A tool that doesn't just nudge numbers, but breaks them apart into their fundamental components. It's like taking a complex machine and disassembling it into simple, manageable pieces you can understand. And that's exactly where we're headed next. This tool has a name. In academic circles, they call it decomposition. But that sounds sterile, like something you do in a chemistry lab. I prefer to think of it as seeing the matrix. It's the ability to look at a number, not as a single solid block, but as a collection of parts, a symphony of place values that you can conduct. And the first piece we're going to play is addition, but not the way you were taught. We need to talk about the way they taught us in school. Right to left. You line up the numbers, start with the little guys on the right, add them up, and if it's more than 10, you carry the 1. Think about how bizarre that is. In every other part of our life, we read, we speak, we think from left to right. We process the most important information first. When you look at the number 742, you don't see the 2 first. You see the 700, the part that gives the number its scale, its magnitude. Yet, for math, we're told to flip our entire mental process backward. It's like being forced to read a book starting with the last word of each sentence. The carry the 1 method is a system designed for pen and paper. It's an accounting trick. It is not and was never designed for the human brain. Your working memory, that mental whiteboard where you hold temporary information, is incredibly limited. For most people, it can only hold a few pieces of information at a time. Asking it to solve a problem backwards while simultaneously holding onto these tiny, floating carried numbers is like trying to pat your head, rub your stomach, and recite the alphabet backwards. It's a recipe for cognitive overload. It's why mental math feels so hard. Not because you're bad at math, but because you were given the wrong software. So let's install an upgrade. From now on, we add from left to right, the way our brains are already wired to think. Let's take a simple problem. 57 plus 34. Your old brain might already be trying to do 7 plus 4 is 11, put down the 1, carry the 1. Stop. Erase that. Let's do it the natural way. Left to right. What are the biggest, most important parts of these numbers? The tens. So let's add them first. 50 plus 30. What's that? 80 easy. You don't even have to think about it. Now just park that number 80 in your head for a second. It's a nice round number. It's easy to hold. Now we deal with the leftovers, the ones. 7 plus 4. That's 11. Now what do we have? We have the 80 we parked and the 11 we just calculated. And what's 80 plus 11? 91. Done. Did you feel that? The lack of strain? You weren't juggling. You were just taking 2 simple steps. Add the big parts, add the small parts, then put them together. It's like building with Legos. You connect the big bricks first to make the foundation, then you add the smaller detailed pieces. Let's try another one a little bigger. 86 plus 47. Okay, left to right. Big pieces first. 80 plus 40. That's 120. Park it. Now the small pieces. 6 plus 7. That's 13. Now combine them. 120 plus 13. That's 133. Notice what happened. There was no carrying. There was just adding. You're handling the numbers in a way that makes sense. This isn't just a party trick. This scales up beautifully. Let's try a 3-digit number. Something that would normally make you reach for your phone. How about 658 plus 273? Looks intimidating, right? Not anymore. We have the tool. Let's disassemble it. Left to right. Hundreds first. 600 plus 200. That's 800. Easy. Park it. Next the tens. 50 plus 70. That's 120. Okay, now we have 2 numbers parked in our head. 800 and 120. Let's just combine those right now to make it simpler. 800 plus 120 is 920. See, we're just adding as we go, building our answer piece by piece. Finally, the ones. 8 plus 3. That's 11. So we have our 920 and we just add the final piece 11. 920 plus 11 is 931. There was no moment of panic, no mental fog, just a calm, clear process. You are no longer wrestling with the numbers. You are leading them. You are their conductor. And this same elegant logic, this same principle of breaking things apart, works just as powerfully for subtraction. In fact, it's even more of a lifesaver here, because if carrying is a pain, borrowing is a nightmare. The whole concept of borrowing and subtraction is a clunky, abstract mess. Take 1 from the tens column, which is really a 10, and add it to the ones column. It's a terrible system for mental calculation, so let's throw it out. Let's use the left-to-right method again. Consider 84 minus 37. The old way would have you borrowing from the 8. It's messy. The new way? Start on the left. We have 84. Let's just take away the biggest part of 37 first. Let's take away the 30. What's 84 minus 30? That's 54. Simple. Now all that's left is that little 7. We just need to do 54 minus 7. And if that feels tricky, you can even break that down. 54 minus 4 gets you to a nice round 50. We still need to subtract 3 more. 50 minus 3 is 47. Done. Let's feel that again. 84 minus 30 is 54. 54 minus 7 is 47. It's a smooth, flowing thought process. Compare that to the stuttering, confusing process of borrowing. It's night and day. It's the difference between gracefully walking down a staircase and tumbling down it. This method shines when the numbers get bigger. Let's try one that's truly awful with the old method. 732 minus 486. Just looking at that, I can feel my second-grade anxiety kicking in. You'd have to borrow from the 3, then you'd have to borrow from the 7. It's a chain reaction of confusion. But with our new tool, it's a walk in the park. Let's disassemble it. Start with 732. First, subtract the biggest part of 486. Subtract the 400. 732 minus 400 is 332. That's our new number. Next, let's subtract the tens. We need to subtract 80. What's 332 minus 80? Well, 332 minus 30 gets us to 302. We still need to subtract 50 more. 302 minus 50 is 252. Still with me? Our new number is 252. Finally, we just have to subtract the ones. We subtract the 6. 252 minus 6. Well, 252 minus 2 is 250. Subtract the other 4. 246. Our final answer is 246. And we did it without a single moment of borrowing. We just took a big problem and broke it down into a series of smaller, laughably easy subtractions. This isn't a trick. It's a fundamental shift in perspective. You're realizing that numbers aren't rigid, scary things. They are flexible. The number 486 isn't just 486. It's also 408 0 and 6. And you have the power to peel those layers away one by one, in an order that makes sense to you. We've learned to add and subtract like a human, not like a calculator. We've disassembled the machine. But what about multiplication? What about a problem like 47 times 8? That seems like a different beast entirely. It seems to require memorization, a pen and paper. But what if I told you that the same principle of breaking things apart can turn this monster problem into something you can solve in your head? In less than 3 seconds. The key is a simple, elegant idea that ancient mathematicians used to build pyramids. And we're going to unlock it next. That idea is the principle of symmetry. It's the art of finding the balance point in a problem, the calm center of the storm. The ancient architects and engineers knew that symmetry creates strength and simplicity. And in mathematics, it creates speed. Let's go back to that monster problem. Let's say you're faced with multiplying 48 by 52. On paper, this is a chore. You'd stack them up, multiply 8 by 2, carry the 1, multiply 4 by 2. You already know the drill and your brain is already dreading the work. It's clunky. It's slow. But using the principle of symmetry, we can reframe the entire question. Instead of seeing 48 and 52 as two separate, awkward numbers, I want you to see their relationship to each other. What's the exact midpoint between them? Well, 50. 50 is a beautiful round, easy number to work with. How far is 48 from 50? It's 2 less. And how far is 52 from 50? It's 2 more. So what we're really multiplying is 50 minus 2 times 50 plus 2. Now, here is the secret that the pyramid builders understood, not through algebra, but through the geometry of squares. Whenever you have this pattern, a number minus a little bit times the same number plus that same little bit, the answer is always the big number squared minus the little bit squared. So 48 times 52 just becomes 50 squared, minus 2 squared. Think about how much easier that is. What's 50 squared? That's 5 times 5 with 2 zeros. 2500. And what's 2 squared? It's 4. So the answer is just 2500 minus 4. 2496. No carrying the 1. No long multiplication. Just a simple subtraction you can do in your head in a flash. This is called the difference of squares method, and it is one of the most elegant and powerful shortcuts in all of mental math. It turns a 2-digit multiplication nightmare into a single simple subtraction. Let's try another one and feel how fast this is. How about 29 times 31? Okay, don't reach for the calculator. Don't even flinch. Find the center. The midpoint between 29 and 31 is 30. The distance from the center is 1. So we have 30 minus 1 times 30 plus 1. The rule says this is just 30 squared minus 1 squared. What's 30 squared? 900. What's 1 squared? 1. The answer is 900 minus 1. 899. You see what's happening here? Your brain isn't just calculating. It's rebalancing. It's seeing the problem not as 2 jagged, awkward numbers, but as a perfect symmetrical square with a tiny piece missing. This is a fundamental pattern in the universe of numbers, a pattern so powerful and intuitive that it helped raise the wonders of the ancient world. They weren't just stacking stones. They were exploiting the fundamental laws of geometry and numbers. Let's push it a little further. How about 67 times 73? This looks much scarier. The numbers are bigger, but the pattern is the same. Don't be intimidated. Trust the method. What's the midpoint between 67 and 73? It's 70. Another beautiful round number. How far are they from the center? 3. You have 70 minus 3 and 70 plus 3. So the problem transforms into 70 squared minus 3 squared. 70 squared is 4,900. 3 squared is 9. The answer is 4,900 minus 9. 4,891. Think about how long that would have taken you with pen and paper. You'd still be on the first line of multiplication. But your mind, armed with this ancient principle of symmetry, just solved it in the time it took me to say the sentence. Now, for those of you who have that little voice in your head saying, "But why does this work? Is it some kind of magic trick?" It's not magic, it's just beautiful, simple logic. Let's peek under the hood for just a second. If you remember any of your high school algebra, you might remember something called FOIL, first, outer, inner, last, for multiplying two expressions. If we have a b times a plus b, the first terms are a times a, which is a squared. The outer terms are a times positive b, which is plus a. The inner terms are negative b times a, which is minus a. And the last terms are negative b times positive b, which is minus b squared. So you get a squared plus up minus b squared. And here's the beauty. The middle part, the plus up and the minus up, they perfectly cancel each other out. They vanish. All you're left with is the first part and the last part. A squared minus b squared. The difference of the squares. It's a perfect self-canceling system. It's the reason this trick is so clean and so fast. So where can you actually use this? Believe it or not, this pattern shows up in the real world all the time. Imagine you're at a hardware store buying tile for a project. You need to cover an area that's 18 feet by 22 feet. The salesperson is fumbling with their calculator. But you see 18 and 22. You instantly find the midpoint, 20. The distance is 2. So it's 20 squared minus 2 squared. 400 minus 4. You know instantly you need 396 square feet of tile. You just outcalculated the computer. Or maybe you're calculating a budget. 35 employees are getting a $45 bonus. What's the total cost? Midpoint 40. Distance 5. It's 40 squared minus 5 squared. 1600 minus 25. The total is $1,575. Every time you do this, you're forging a new pathway in your brain. You're teaching it to stop seeing multiplication as a brute force task and start seeing it as a search for elegant patterns. It's like learning to read. At first, you sound out every single letter. It's slow, it's painful. But with practice, you stop seeing letters. You start recognizing whole words, whole patterns in an instant. That's exactly what we're doing with numbers. We're going from sounding them out to reading them fluently. This difference of squares is a powerful tool in our mental workshop. It's like having the perfect, specialized saw for a very specific type of cut. It's incredibly efficient when you have two numbers that are an equal distance from a nice, round number. But what happens when the wood is a different shape? What do you do when the numbers aren't a neat pair like 48 and 52? What about a problem like 97 multiplied by 96? They're close together, but there's no neat whole number midpoint. The average is 96.5. And suddenly our elegant trick of whole number squares seems to break down completely. It feels like we're back to square one, staring at a brick wall, forced to go back to the slow, painful method of long multiplication. But what if I told you there's another secret? A sister technique to this one that makes multiplying numbers that are close to 100, or even 1000 so mind-blowingly easy it feels like you're cheating. This next technique is the kind of thing traders on the chaotic floors of the stock exchange used to make lightning-fast calculations before computers dominated everything. And it all starts with one simple perspective-shifting question. What if the question wasn't, what is 97 times 96? What if the real question, the smarter question, was, how far are 97 and 96 from the easiest number to multiply with in the entire universe? That number, of course, is 100. This shift in perspective is the key that unlocks one of the most powerful mental math techniques ever devised. It's called the base method or the reference number method, and it's going to feel like you've just discovered a cheat code for reality. Let's stick with that problem. 97 times 96. Thinking about it the old way is a mess. You're trying to multiply 6 times 7, carry the 4, then 6 times 9, add the 4. Your brain is already getting cluttered and you haven't even started the second line of multiplication. It's slow, it's clunky, and it's incredibly prone to error. Now let's use the trader's method. Our base, our beautiful clean reference number is 100. First step. How far is each number from that base? Well, 97 is 3 less than 100, so we'll just hold on to the number -3. And 96 is 4 less than 100, so we have -4. Keep those two little numbers in your mind. -3 and -4. These are our differences. Second step. This is where the magic happens. Take one of the original numbers, say 97, and subtract the other number's difference. So that's 97 minus 4. What does that equal? 93. Now, just for fun, let's try it the other way. Take 96 and subtract the first number's difference. 96 minus 3. What does that equal? 93 again. It works every single time. This number, 93, is the first part of your answer. Because our base was 100, this isn't just 93, it's 93 hundredths. So we have 9,300. We're almost done. Third and final step. Take those two little difference numbers, -3 and -4, and multiply them together. A negative times a negative is a positive. 3 times 4 is 12. Now just add that to the number you were holding. 9,300 plus 12 gives you 9312. And that is the exact perfect answer to 97 times 96. Take a second to let that sink in. We just solved a complex multiplication problem with a simple subtraction and a tiny multiplication. No carrying numbers, no long-form process. Just pure simple logic. Let's do another one, faster this time so you can feel the speed. 98 times 95. Okay, base is 100. The difference is 98 is -2. 95 is -5. Cross subtract. 98 minus 5 is 93. That's our first part. 9,300. Multiply the differences. -2 times -5 is +10. Add them together. 9,300 plus 10 is 9,310. Boom. Done. Go ahead, check it on a calculator if you don't believe me. You can do this in your head faster than most people can type the numbers into their phone. Now you might be thinking, okay, that's cool for numbers below 100, but what about numbers that are bigger? It's the exact same logic. Let's try 104 times 108. Base is still 100. The difference is, this time they're positive. 104 is +4 from 100. 108 is +8. Now instead of cross-subtracting, we cross-add. Take 104 and add the other difference, 8. 104 plus 8 is 112. That's the first part of our answer. 112 hundredths, so 11,200. Now multiply the differences. Positive 4 times positive 8 is 32. Add them together. 11,200 plus 32 is 11,232. That's your answer. You're now multiplying 3-digit numbers in your head in seconds. This is a legitimate superpower. But the real test of any great system is how it handles the weird cases. What happens if one number is above the base and one is below? Let's take on 105 times 96. This is where the method proves its genius. Base is still 100. The difference is 105 is plus 5, but 96 is minus 4. The rule is the same. Let's cross-calculate. We can do 105 minus 4, which is 101. Or we can do 96 plus 5, which is also 101. The system holds. So the first part of our answer is 101 hundredths, or 10,100. Now, for the second part, we multiply our differences. Positive 5 times negative 4. That gives us negative 20. So our final step is 10,100 plus negative 20, which is the same as 10,100 minus 20. The answer is 10,080. This is the beauty of it. The logic is so pure it handles every combination you can throw at it. You're not just memorizing a trick. You're understanding the fundamental relationship between the numbers. And this is where we take it to a level that will make you feel like a math prodigy. It doesn't just work with a base of 100. It works with any base. Let's try something that seems horrible at first glance. 48 times 47. Now, we could use 100 as a base, but the differences minus 52 and minus 53 are huge and hard to multiply. The smart question is, what's a better base? A nice round number that's close by. 50. Let's use 50 as our base. The difference is from 50. 48 is minus 2. 47 is minus 3. The cross calculation is the same. 48 minus 3 is 45. Or 47 minus 2 is 45. Now here's the one tiny adjustment we have to make. Our result isn't 45 hundredths. It's 45 times our base. So it's 45 times 50. And that's easy to do in your head. 45 times 100 is 4,500, and we just cut that in half. So 2250. That's the first part of our answer. Now for the second part. Multiply the differences. Negative 2 times negative 3 is positive 6. Combine them. 2250 plus 6 is 2,256. That's your answer. 48 times 47 is 2,256. What you've just learned is more than a party trick. It's a complete restructuring of how you see multiplication. You're no longer a grunt, following a rote, multi-step process. You're a strategist. You're finding a convenient landmark, a base, and then simply calculating the relationships to that landmark. You're seeing the matrix behind the numbers. This is what true number sense feels like. It's the ability to flexibly manipulate numbers, to see them not as fixed values, but as interconnected concepts. This is why those traders could scream out calculations in a chaotic pit. They weren't doing third-grade math in their heads. They were using a more elegant, more intuitive system. They were looking at problems like 98 times 103 and instantly seeing 100 minus 6. They were seeing the answer before most people could even process the question. This base method is a cornerstone of mental calculation, turning what seems complex and intimidating into something simple and, dare I say it, fun. It transforms multiplication from a chore into a puzzle. But multiplication is an act of building up. What about the opposite? What about tearing numbers apart? I'm talking about division. For most people, mental division is a black box of anxiety. Dividing a 3 or 4-digit number by another number in your head seems completely impossible. But what if I told you there's a way to estimate complex division problems with shocking accuracy, often in less than 5 seconds? It involves a completely different way of looking at fractions, and it's so simple you'll wonder why they never taught you this in school. This is a technique for what I call fuzzy math. But the results are anything but fuzzy. The official name is the compatible number strategy, and it's based on a simple, beautiful idea. Most ugly division problems are just simple problems in disguise. Our brains hate dealing with jagged, complex numbers like 487 divided by 79. It's like trying to fit 2 weirdly shaped rocks together. It doesn't work. But our brains are fantastic at dividing simple, round numbers. So, the trick is to slightly change the ugly numbers into pretty ones that play nice together. Let's take that exact problem. 487 divided by 79. Don't even think about long division. Don't reach for your phone. Just look at it. The number we're dividing by, 79, is the key. What friendly number is it super close to? 80, of course. So, let's just pretend the problem is something divided by 80. Now look at the other number, 487. We need to change it into a number that's compatible with 80. What does that mean? It means we want a number that 80 goes into easily. Well, forget the 0 on 80 for a second. Just look at the 8. What number close to 487 is easily divisible by 8? Look at the first two digits of 487. 48. Does 8 go into 48? Yes, goes in exactly 6 times. It's a perfect match. So, let's change 487 into the much friendlier, compatible number 480. Look what we've just done. We've transformed the ugly, intimidating problem of 487 divided by 79 into the stunningly simple problem of 480 divided by 80. And you can solve that in your head in less than a second. The zeros cancel out. You're just left with 48 divided by 8. The answer is 6. Now you might be thinking, okay, that's a neat trick, but it's just a rough estimate, right? The real answer is probably way off. Is it? Let's pull out a calculator and check. 487 divided by 79 is 6.16. Our 5-second mental estimate was off by less than 3%. For almost any real-world situation, figuring out your gas mileage, splitting a group cost, checking if a store offer is a good deal, an answer of 6 is more than good enough. You just solved a nasty division problem in your head, faster than someone else could unlock their phone. Let's try a monster. Something you would never ever attempt in your head. 3,410 divided by 48. This looks like a nightmare. It's something you'd see on a math test designed to make you sweat. But we're not going to sweat. We're going to find the compatible numbers hidden inside. First, look at the divisor 48. What's the closest, friendliest number? 50, easy. Now we have a new mission. We need to find a number close to 3,410 that 50 will divide into cleanly. Remember, dividing by 50 is easy. We just need to find a multiple of 50. Let's look at the first few digits of 3,410. 341. What's a multiple of 5 that's close to 341? Well, 5 times 6 is 30. 5 times 7 is 35. 35 is much closer to 34. So let's aim for a number that starts with 35. The perfect compatible number would be 3,500. It's close to 3,410, and it's a beautiful round multiple of 50. So, our nightmare problem, 3,410 divided by 48, has become the simple, elegant problem of 3,500 divided by 50. And this is a piece of cake. First, you can cancel a 0 from both sides. Now it's just 350 divided by 5. Still too hard? No problem. Just ignore the 0 for a second. What's 35 divided by 5? It's 7. Now just add that 0 back on. The answer is 70. We just estimated that 3,410 divided by 48 is about 70. The whole process took maybe 10 seconds. Now for the moment of truth. The exact calculator answer is 71.04. Again, we are incredibly close. We were off by the tiniest fraction. Imagine you're managing a project budget. You have $3,410 left to spend over the next 48 days. You need to know roughly how much you can spend per day. Do you need the exact answer of $71.04? Or is knowing you have about $70 a day all you need to make a smart decision? This is not just a math trick, it's a practical life skill. This works because we are preserving the ratio between the numbers. When we adjusted 48 up to 50, we also adjusted 3,410 up to 3,500. By nudging both numbers in the same direction, we keep the final answer in the same ballpark. We're essentially finding a much simpler fraction that is almost equal to the messy one. Now it's important to know that this is an art as much as it is a science. The friendly number isn't always a multiple of 10. Let's try one more. What about 152 divided by 23? Following our rule, we could round 23 down to 20. Then we'd look for a multiple of 20 near 152. Both 140 and 160 are close. The answer is probably somewhere in between 140 divided by 20, which is 7, and 160 divided by 20, which is 8. So our estimate is somewhere between 7 and 8. That's helpful, but we can do better. What if, instead of rounding 23 to 20, we rounded it up to 25? 25 is one of the friendliest numbers in all of mathematics because our brains think in terms of quarters. How many quarters are in $1.52? Well, there are 4 quarters in $1, so that's 4. And there are 2 more quarters in the remaining 52 cents. 4 plus 2 is 6. So 152 divided by 25 is about 6. Let's check the calculator. 152 divided by 23. The real answer is 6.6. Our estimate of 6 by using 25 instead of 20 was much closer and just as easy to figure out. This is the key takeaway. You're not just memorizing a rule. You're developing what mathematicians call number sense. It's an intuition, a feel for how numbers relate to each other. You start seeing that division isn't a rigid mechanical process. It's a flexible, creative puzzle. You're the detective, looking for the simple, compatible clues hidden inside the complex problem. You're not just calculating, you're strategizing. This is the kind of thinking that separates people who are good at math from people who truly understand math. It's the difference between following a recipe and being a chef who can invent new dishes. You're learning to be a chef with numbers. This one skill, the ability to estimate division quickly, will pay dividends in every area of your life. From the grocery store to the boardroom, you'll be able to make faster, smarter, more confident decisions, all because you've learned to see the simple patterns that are hiding in plain sight. So we've conquered intimidating division. But what about the single most common, most frustrating type of math we face every single day? I'm talking about percentages. Tipping at a restaurant, calculating a sale discount, figuring out tax. It's everywhere. What if I told you there's a simple, reversible trick that lets you calculate percentages like 32% of 75 in your head, just as easily as you could calculate 75% of 32? It's a law of mathematics most people have never heard of, and it's going to completely change the way you shop and dine out. This powerful, almost magical principle is based on a simple, beautiful truth of mathematics. Multiplication is commutative. That just means a times b is always the same as b times a. And since percentages are just a form of multiplication, the same rule applies. So, a percent of b is always the same as b% of a. Let's go back to that problem, 32% of 75. Your brain immediately short-circuits. It's a mess of decimals and long multiplication. But what if we just flip it? What's 75% of 32? Well, 75% is just 3/4. And you know how to find 3/4 of a number. You just cut it in half and then cut it in half again. Half of 32 is 16. Half of 16 is 8. So 1/4 of 32 is 8. We need 3/4, so we just do 8 times 3. The answer is 24. 32% of 75 is 24. You can do that in your head in about 5 seconds, while everyone else is still fumbling to unlock their phone and find the calculator app. Think about the implications. You're at a restaurant. The bill is $60 and you want to leave a 15% tip. Calculating 15% of 60 is doable but a little clunky. You find 10%, which is $6. Then you need half of that for the other 5%, which is $3. 6 plus 3 is 9. Pay $9. Not bad. But watch this. Let's flip it. What's 60% of 15? 60% is just 6 times 10%. 10% of 15 is 1.5. 6 times 1.5? That might seem tricky, but just think of it as 6 times 1, which is 6 plus 6 times 0.5, which is 3. 6 plus 3 is 9. $9. It's the exact same answer, but you approached it from a completely different and often easier angle. This trick is your new secret weapon for shopping. You see a pair of jeans for $80, and they're 16% off. What's 16% of 80? It's a nightmare calculation. But what's 80% of 16? It's so much easier. 80% is just 8 times 10%. 10% of 16 is 1.6. Now you just have to calculate 8 times 1.6. Don't panic. Break it down. 8 times 1 is 8. 8 times 0.6 is 4.8. Add them together. 12.8. The discount is $12.80. You just did that in your head. This isn't just a trick. It's a fundamental shift in perspective. It teaches you that when a problem looks hard, you shouldn't just brute force it. You should walk around it, look at it from a different angle, and see if there's an easier way in. And now, for the technique that feels less like math and more like a superpower. We've been building up to this. We've mastered addition, subtraction, and some clever multiplication shortcuts. But what about the big one? What about multiplying any two-digit number by any other two-digit number instantly in your head? I'm talking about calculating something like 43 times 61 faster than someone can type it into a calculator. This is the boss level of everyday mental math, and the method is so elegant, so simple, it's almost criminal that they don't teach this in school. It's often called the crisscross method, and it relies on a simple three-step visual pattern. Let's take an example. We'll start easy. 21 times 32. Now the old way, you'd write them on top of each other. You'd do 2 times 1, then 2 times 2. Then you'd put a 0 on the next line, do 3 times 1, 3 times 2, and then add the two big numbers together. It's a multi-step process with a lot of room for error. It's not designed for your brain. It's designed for paper. The crisscross method is designed for your mind. It gives you the answer in one single line from right to left. Here's how it works. Picture 21 above 32. Step 1 is simple. Multiply the numbers on the right, the vertical ones. In this case, it's 1 times 2. That's 2. This is the last digit of our final answer. So we know our answer ends in 2. Easy enough. Step 2 is where the magic happens. This is the crisscross. You multiply the diagonally opposite numbers and add them together. So you multiply the 2 on the outside, 2 times 2 is 4. And the 2 on the inside, 1 times 3 is 3. Now add those two products together. 4 plus 3 is 7. That's the middle digit of our answer. So far we have 7 too. Step 3 is just like step 1 but on the left side. Multiply the numbers on the left, the vertical ones again. That's 2 times 3, which is 6. That's the first digit of our answer. Now let's put it all together. The first digit was 6. The middle digit was 7. The last digit was 2. The answer is 672. No carrying, no multiple lines of addition, just a simple three-step pattern. Multiply vertically on the right, crisscross and add. Multiply vertically on the left. It's an algorithm for your brain. Let's try another one a little harder. 34 times 42. Picture it. 34 above 42. Step 1. Multiply the right side. 4 times 2 is 8. Our answer ends in 8. Step 2. The crisscross. Outside numbers. 3 times 2 is 6. Inside numbers. 4 times 4 is 16. Add them together. 16 plus 6 is 22. Now hold on. We can't just put a 22 in the middle. Just like regular addition, you write down the last digit, which is 2, and you carry the other digit, the other 2, over to the next step. So our middle digit is 2, and we have a 2 in our back pocket to carry. So far our answer looks like 2, 8. Step 3. Multiply the left side. 3 times 4 is 12. But remember that 2 we carried over? We have to add it now. 12 plus the 2 we carried is 14. That's our first part of the answer. So what do we have? We have 14, then the 2, then the 8. The answer is 1,428. You can check it on a calculator. It's perfect. And you did it following 3 simple steps. This method is a workout for your working memory. It trains your brain to hold and manipulate numbers in a fluid, dynamic way. Let's do a really tough one to see just how powerful this is. 57 times 86. This looks terrifying. But we have a system. We have a pattern. We don't need to be scared. Picture it. 57 above 86. Step 1, right side. 7 times 6 is 42. We write down the 2 and we carry the 4. Our answer ends in 2. Step 2, crisscross. Outside, 5 times 6 is 30. Inside, 7 times 8 is 56. Add them together. 30 plus 56 is 86. But don't forget, we carried a 4 from the last step. So we add that too. 86 plus 4 is 90. Okay, so we write down the 0 and carry the 9. Our answer so far is 0, 2. Step 3, left side. 5 times 8 is 40. And we have that big 9 we carried over. 40 plus 9 is 49. That's the first part of our answer. Let's assemble the final number. We have 49, then the 0, then the 2. The answer is 4,902. And you did it. You took a monster of a multiplication problem and you solved it in your head using one elegant, repeatable process. This isn't just about getting the right answer. It's about the feeling of control, the feeling of power. It's the confidence you get from knowing that you can tackle complexity and break it down into simple, manageable steps. This is what building a better brain feels like. It's not about memorizing 1,000 facts. It's about learning a few powerful systems that allow you to generate 1,000 answers. You're not just learning tricks, you're upgrading the very software your mind runs on. And the most incredible part of this entire journey isn't the tricks themselves. It's not the speed or the ability to impress your friends. The real secret, the key that unlocks all of this and takes you from just knowing these tricks to truly mastering them, is something much deeper. It's a fundamental shift in how you view your own intelligence, and it's the one thing that separates people who learn a few party tricks from those who build a genuinely sharper, faster, and more powerful mind. That fundamental shift isn't about becoming a human calculator. It's about becoming an architect of your own thoughts. It's the realization that numbers, problems, and challenges aren't monolithic, terrifying blocks of stone. They are structures built from smaller, simpler, more manageable bricks. And once you see the bricks, you can take the whole thing apart and put it back together any way you want. This is the master key. This is the final and most important mental model that underpins every single trick we've discussed. It's the principle of decomposition and recomposition, breaking things down and building them back up. Most people see a problem like, say, 47 times 8 and their brain freezes. It's a single ugly operation. But a trained mind doesn't see one problem. It sees a collection of simpler problems hiding in plain sight. Sees the bricks. 47 isn't just 47. It's 40 plus 7. It's a friendly round number and a small, easy single digit. So 47 times 8 instantly becomes two separate, much easier problems: 40 times 8 and 7 times 8. You've just decomposed the challenge. Now you solve the simple parts. 40 times 8? That's just 4 times 8, which is 32 with a 0 on the end. 320. Easy. And 7 times 8? That's 56. Basic multiplication tables. You've handled the bricks. Now for the final step. Recomposition. You just add your two results back together. 320 plus 56. What's that? 376. There's your answer. No calculator, no stress, no mental block. You just dismantled the problem, solved the pieces, and rebuilt the solution. This isn't a trick. This is a strategy. This is the essence of thinking. Let's try a scarier one. Let's take 387 multiplied by 15. Your gut reaction might be to reach for your phone. It looks like a beast. But let's apply the framework. Let's look for the bricks. The number 15 is screaming to be decomposed. What is 15? It's 10 plus 5. So the problem isn't 387 times 15. It's really, what is 387 times 10? Plus 387 times 5? Suddenly, the beast is starting to look a lot more tame. The first part is incredibly easy. 387 times 10 is just 3,870. We have our first big piece of the answer. Now for the second part. 387 times 5. This might still seem a little tricky, but wait. We just figured out what 387 times 10 is. And what is 5? It's exactly half of 10. So the answer to 387 times 5 must be exactly half of the answer to 387 times 10. We just need to find half of 3,870. Again, don't look at it as one big number. Decompose it. What's half of 3,800? Well, half of 38 is 19, so half of 3,800 is 1,900. And what's half of 70? That's 35. So, half of 3,870 is 1,900 plus 35, which is 1,935. Now we have both of our bricks. We have 3,870 from the first part, and 1,935 from the second part. The last step is to put them back together. Recompose. We need to add 3,870 and 1,935. Again, let's break it down to make it easy. Let's add the thousands first. 3,000 plus 1,000 is 4,000. Now the hundreds. 800 plus 900 is 1,700. Now the tens and ones. 70 plus 35 is 105. Now we just reassemble our final pieces. 4,000 plus 1,700 is 5,700. Add the 105 and you get 5,805. And that is the correct answer to 387 times 15. You just solved a complex 3-digit by 2-digit multiplication problem in your head, not by having a supercomputer for a brain, but by refusing to see the problem as it was presented. You looked for the seams, you found the bricks, and you took control. This is the profound shift I'm talking about. Because this skill, this instinct to break down complexity, is not a math skill. It is a life skill. It is the single most powerful problem-solving tool you will ever possess, and you can apply it to absolutely everything. Feeling overwhelmed by a massive project at work? It's not one project. It's a series of smaller, definable tasks. Launch the new product is terrifying, but draft the announcement email, schedule the social media posts, and confirm the inventory are manageable. You decompose the mountain into a pile of rocks you can move one at a time. Trying to learn a new language? Learn Spanish is a vague, intimidating goal. But learn 10 new vocabulary words today. Practice verb conjugation for 15 minutes, and listen to one Spanish song or concrete actions. You decompose the fluency into daily reps. Want to get in shape? Get in shape is a recipe for failure. But do 20 push-ups, walk for 30 minutes, and swap soda for water with lunch are the bricks that build the temple of fitness. You are breaking down the overwhelming into the achievable. Every time you do this, you are doing more than just solving a problem. You are training your brain to be calm and analytical in the face of complexity. You are replacing the panic of "I can't" with the curiosity of "How can I break this down?" You are building what psychologists call cognitive flexibility, the ability to pivot, to see things from different angles, and to adapt your strategy. This is the true gift of mental math. The numbers are just the gymnasium. The real workout is for your entire way of thinking. When you can confidently break down a number like 387, you start to believe you can break down anything. A difficult conversation you need to have. A financial goal that seems out of reach. A new skill you thought was too hard to learn. The underlying process is identical. You find the simple components hidden within the complex system. This is why people who are good at this kind of thinking often seem to have more willpower or discipline. It's not that they have more raw grit. It's that they don't exhaust their mental energy by staring at the entire terrifying mountain. They just focus on the next step, the next brick. They make progress, which builds momentum, which fuels motivation. It's a powerful, self-reinforcing cycle that starts with the simple decision to not accept a problem at face value. So, where do you go from here? You've seen the tricks, you've learned the techniques, and now you understand the core philosophy that ties it all together. The answer is to start playing. To start getting your reps in. Don't treat this as a chore. Treat it as a game. The world is now your mental gymnasium. When you're at the grocery store and you see a price that's 25% off, don't pull out your phone. Challenge yourself. What's 10% of that price? Double it. Add half of the 10% amount. Play with the numbers. When you see a license plate, add the numbers up. When you're calculating a tip, use the 10% method and then add half. Every single time you do one of these small calculations, you are casting a vote for a new identity. You are telling your brain, I am the kind of person who is in control. I am sharp. I am capable. You are literally rewiring your neural pathways to make this kind of thinking your default setting. The goal was never to just learn how to multiply 47 by 8. The goal was to fundamentally upgrade your cognitive operating system, to install a new piece of software in your mind that automatically looks at complexity and sees opportunity. An opportunity to analyze, to deconstruct, and to solve. The confidence that this brings will bleed into every other area of your life. You'll become a better problem solver at work, a more creative thinker in your hobbies, and a more resilient person when facing life's inevitable challenges. You have the tools. You have the framework. The only thing left is to begin. Don't wait for a special occasion. Start today. Start right now. The next time you see a number, any number at all, don't just let it be a passive piece of information. Engage with it. Break it down. Put it back together. See it not as a math problem, but as an opportunity to sharpen the single most powerful tool you will ever own: your mind.